Imagine holding uh, a single 41-foot HDMI cable that costs exactly $335.
Yeah, that's definitely a lot for a single cable.
Right. And from the outside, I mean, it looks like something you'd fish out of a discount bin at a hardware store. But inside, it is silently firing microscopic lasers to transmit just massive amounts of data at light speed.
That's a perfect disguise, honestly. And so today, we are deep diving into the DVIGear DVI-2512-AOC.
Catchy name.
Right. But our mission for you today is to figure out why this specific piece of hardware is a critical marvel of professional AV engineering, rather than just a really expensive cord.
Yeah, because to justify dropping over $300 on a cable, you really have to understand, the fundamental physics problem it's trying to solve.
Exactly. When you push huge 4K video signals over 40-plus feet of standard copper wire, the signal just degrades.
It's like trying to blast a high-pressure fire hose of water through a long drinking straw, right?
That is a great analogy, yeah.
Because the narrow straw creates this massive bottleneck, and the friction against the sides of that long straw just saps the energy, until the water barely trickles out the other side.
Right. And in cables, that friction is electrical resistance. So to fix that, DVIGear uses what's called Active Optical Cable technology, or AOC.
AOC, okay.
Yeah. So inside this cord, you've got 6 standard copper wires, but they run right alongside 4 polyfluorinated optical fibers.
Wait, so instead of fighting electrical resistance, it's actually converting the video signal into light?
Precisely. At the connector, there are these components called multi-mode VCSELs. Basically, they're microscopic lasers.
Lasers!
Yeah.
Inside an HDMI cable.
I know, it sounds crazy.
Yeah.
But they pulse infrared light, specifically at an 850 nanometer wavelength, which is like the absolute perfect frequency to travel through these fibers without scattering.
Wow. So because the data is traveling as light instead of electricity, it just bypasses that copper resistance completely.
Exactly, which explains the speed. I mean, it can carry 18 gigabits per second. That gives you absolutely flawless 4K video at 60 hertz.
Over really long distances, too. But wait, if there are tiny lasers firing inside the connector, converting electricity into light usually takes, serious juice.
You would think so, yeah.
So do you have to plug this cable into a wall outlet? Because I feel like that would be a total nightmare for AV installers trying to keep things clean.
It totally would be. But that's where the engineering really shines here. Those microscopic lasers are hyper efficient. The cable actually draws power directly from the HDMI port on your device.
Oh, really?
Yeah, it pulls less than a 0.235 watts. It's barely sipping power, so you completely avoid the need for bulky external power adapters cluttering up a server rack.
Okay, I do have a major hang-up here, though. We're talking about optical fibers, which are, essentially tiny tubes of glass or specialized plastic carrying light.
Right.
If I'm spending over $300 on a 40-foot cord for a professional install, someone is eventually going to step on it.
Oh, guaranteed.
So wouldn't putting heavy work boots on tiny fiber optics just instantly crush that investment?
It's a completely valid fear. But the internal structure is built for exactly that kind of abuse. The crush resistance is actually rated at over 500 newtons.
Wait, meaning what in the real world?
Meaning a technician in heavy boots could step directly on this cable on a hard concrete floor, which is about 112 pounds of direct pinpoint force, and the internal fibers won't shatter.
That is wild.
Yeah, and the tensile load rating is over 200 newtons, so an installer can yank it through a wall with about 45 pounds of pulling force without snapping anything inside.
Okay, but what about corners? Because I've tried to push standard HDMI cables flush against a wall behind a TV, and they just refuse to bend.
They are super stiff, yeah.
Right, so with fiber optics, if you bend it too far, doesn't the light just stop reflecting properly, or, the fiber just snaps?
With standard glass fiber, absolutely. But because these use a flexible polyfluorinated composite, the minimum bend radius is an incredibly tight 2 millimeters.
2 millimeters. I mean, you can practically fold it in half.
You pretty much can. Plus, it features detachable docking connectors, so you can easily snake it through tiny conduits.
Oh, that's smart.
And once it's through, locking pins ensure it doesn't accidentally unplug.
Mm-hmm.
It's also plenum rated, meaning the outer jacket meets strict commercial fire codes for safe installation inside walls and ceilings.
And since the heavy video data is traveling as light rather than electrical current, I'm guessing it isn't generating electromagnetic interference.
Spot on. It has a remarkably low RFI and EMI profile.
Right.
It won't give off radio frequencies, and more importantly, it won't pick them up. If you're installing this in a hospital with sensitive MRI equipment or, a broadcast studio packed with wireless mics.
That interference-free performance is mandatory, yeah.
Absolutely mandatory, not just nice to have.
So, bringing this all together for you listening, when you buy a cable like this, you aren't just paying a premium for an extra 40 feet of reach.
No, not at all.
You are investing in bulletproof, interference-free infrastructure.
It really shifts your perspective on modern architecture, honestly. When you walk through a massive stadium, a hospital, or a high-end corporate office, you're walking through a space powered by an invisible nervous system.
It's wild to think about. I mean, how much of our modern world, like live broadcasts, medical imaging, stadium displays, relies entirely on massive streams of fragile data?
Yeah, silently protected by optical cords we never even see.
Exactly. It's definitely something to ponder the next time you glance at a tangled $5 cable in a bargain bin and realize that sometimes you actually do need an optical fire hose.